Hello again. We are now going to do a quick guide on how to train ourselves about how well we have aligned the telescope in the previous guide. It turns out when you do a sky alignment or a one-star alignment, any type of alignment, the telescope might not be exactly where we think it's supposed to be, but we can train ourselves to figure out what the alignment solution was from the previous video. So what I'm going to have Matthew do is have Matthew select menu on the hand paddle, and then using the arrow buttons on the right hand side, he can scroll down to a menu option which is called Go to RA Dec. That stands for Go to RA Declination. You can hit enter, and what does it say next?
It says enter right ascension.
Right, so there's two options. Sometimes it says enter name or enter right ascension declination. You can use the arrow buttons to get to the enter right ascension declination. And what we've provided for every RECON event in the event detail page is a list of 4 to 5 stars that are close by to our target, and we are going to look at them one by one and figure out where the telescope thinks it is pointing. So for this object that we're going to look at, the first star on the list is called Aldebaran. So I'm going to read off the coordinates of right ascension and declination to Matthew. So if you can type in right ascension 04, 36, 54.1. If you ever mess up with this, you can use the back button to go back to change a number. You can hit enter. And then at this point, we want to type in positive, and there's sometimes a positive or negative. You can use the arrow buttons on the right-hand side to change it from positive to negative. Then you hit enter, and the number is 16, 32, 33. Hit enter. And what the telescope is doing now is it's trying to point to this very, very bright star, Aldebaran, in the constellation of Taurus. And because it's such a bright, obvious star, if we got it right and it shows up somewhere in the camera, we'll know where the telescope thinks the center of the camera is. Cue music. This is the telescope moving to Aldebaran, which will take a little bit of time. We've already aligned the telescope, so hopefully we're going to see a bright star showing up, and you can go ahead and zoom into this. We can look and see if we have a bright star showing up somewhere in the field of view of the telescope. Ha-ha! There it is! Notice that given the way we did the alignment, the telescope thinks that right now it has centered Aldebaran exactly in the center of the camera, but in reality it's down and to the left in the field of view. At this point we have a couple options. We can just know that this is where the center kind of is, or Matthew can actually change the motor speed to 6 or 5, which is a medium motor speed, like 5, and he can tap it a couple of taps to the left and count the taps as you do it.
3.
Which way are you tapping there, Matthew?
I'm moving it.
Okay.
You want me to move it to the center?
So what you would want to do is you want to figure out how many taps does it take to get the star into the middle of the frame. So let's go ahead and do that. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 up and 10 over is kind of where we think the center is. Again, this was a very bright, obvious, and easy target star, and so we're going to be looking at a star that's very faint, and so we want to use these stars as a guide to getting to the actual star that we're looking for. The next target star to train ourselves is called Mirfac, and so again, what you do is use the Go to RA Dec function. The new coordinates for Mirfac off my sheet are 03, 25, 33.3. Hit enter, and then positive, enter, 49, 55, 15. Whoa! So it moved a little bit in declination, and now it's going to spin around and get closer to where Mirfac is. For perspective, Aldebaran was actually 33 degrees away from our target, and Mirfac, which is a dimmer star, is only 3 degrees from our target. So we're getting closer and closer to the target star with each of these training stars that we look at. Also, Mirfac is not as bright as Aldebaran. So what we see in the screen will be slightly dimmer than the Aldebaran star that we were just looking at. This takes an extra, 3 or 4 or 5 minutes, but it's a very systematic way in which you can always know that you're training yourself to know where the pointing of the telescope is. So we're looking here now as it slows down. We're hoping a very bright star, obvious star, shows up in our camera. There it is! Excellent. Notice it's still on the left-hand side, but because we're now closer to the target field, it's actually in a slightly different position. It's not in the lower left. It's now kind of in the center left. And so again, you can know that this is where the center of the telescope thinks it is, or Matthew can do the number of taps to get it into the center. Go for it. Yeah. Tapping and tapping. Don't panic. It's okay. The star's still there.
4, 5. Right?
How many was that?
That was 10 taps.
Yeah, so again, 10 taps to get it over into the center. Now we will go to our third star. So you'll hit enter, go to RECON. The third star is, oh look, ppm 840236. That is a fainter star that is even closer to our target. It is at coordinates 03, 30, 38.5. Hit enter, plus 46, 55, sorry, 46, 59, 54. No, sorry, 46, 59, 45. Now this star is only 0.3 degrees, so a third of a degree from our target, and it's a 6th magnitude star, so it's about 100 times fainter than the last star that we were looking at. And it is likely this one. We know that it's this one because we've trained ourselves that the telescope thinks that the pointing solution is over here to the left. So we're now going to tap that the number of times to see if we can get the star into the center. About 9 or 10 again? Yeah. Okay, cool. Should we do one more or should we go to the target?
Let's do one more.
Okay, one more. So this is the last star training star. You can go to RECON, 03, 31, 33.1. And plus 46, 31, 31. This guy is now a even fainter star. It's a 9th magnitude star. It is only a quarter of a degree from where we're trying to get to. And so this is the star. Again, fainter and fainter. And so what we've kind of trained ourselves is that when we actually get to our target, we're going to be looking right here as the place to find the field. And if you want to move it over, the right number. You don't have to do this last step of moving it over. If you actually can just know that you're going to look in that part of the field, that's completely fine as well. How many was that?
10.
10?
Yes.
Each time, 10.
Very
All right.
consistent.
And then finally our target. This is the star that's actually going to be occulted. 03, 30, 11.4, plus 46, 38, 31. This is actually a 16th magnitude star, so this is 100 times fainter than that last star, which was 100 times fainter than the previous star, which was 100 times fainter than the previous star. So this is actually 1,000,000 times dimmer than the first star, Aldebaran, we're looking at. And so we are actually going to have a really hard time knowing that we're looking exactly the right place, except that we know that this is where we think the star is. At this point, because we're dealing with such a faint star, it's actually a good opportunity to change the sense up on the camera. So Matthew's going to press and hold down the center button. He's going to go down an arrow and change the sense up from ×8 to ×128, which is a maximum integration time, so you're getting the longest exposure, and bright and dim stars will look brighter. He goes back up and goes back up to the save menu and hits enter. In a couple of seconds, this field will get brighter and brighter as time goes by. And at this point, you could probably do your taps, right? You could probably tap your 10 times. 1, 2, 3, 4, 5. Okay, so he's done the same number of taps. Therefore, we think that this is our target star that we're trying to image. The last part of this process, and this is the most, hopefully the most rewarding part of the process, unless it didn't work out, in which case it's frustrating, is that we have a star chart here. And the star chart lists the stars that we'd expect to see, as well as a picture that shows what star field or star pattern we should be looking for. So if we can now compare, I'm going to pop over here. And what we're going to do is we're going to look and compare of whether we can actually find the same patterns in this field as what we're seeing in the camera. And what I see here are 2 bright stars, 2 faint stars, and a 3rd star. So there's kind of 5 stars that make up this little kind of croissant shape. I don't know, is that a croissant? What is that? Whatever it is. And those actually match these 5 stars. So these 5 stars are the same as those 5 stars. There's also a star up above it, which is that star. And so our target is between these 2 stars, and it's actually right there, even though it's super, super faint, because again, it's a 16th magnitude star, and you wouldn't know that that was the right target unless you'd done the star training, but we know that we are now pointed on the field. It matches what we're wanted to see, and so we're basically ready to now record the occultation event. Hopefully this has happened about half an hour, 20 minutes, or at least 10 minutes before the event, so you're all ready and good to go before the occultation happens. So, any questions?
No, thanks.
You're welcome. Thank you. Good luck. It won't always be this easy. Sometimes you'll get frustrated. Just kind of deal with it. If you ever point to the first star and it doesn't show up in the camera, you can actually look in the TELRAD. And remember, that's a super bright star, so you'll be able to see the bright star in the TELRAD, and so you can know whether you have to go left or right to get the bright star into the frame, and then you'll always be able to do the same procedure for the next star and the next star and the next star using that same number of taps.